Okay, so I want you to follow along. I want you to identify any mistakes you've made. If I didn't write on your AC, then you get 100% no matter what. Even if you get every single question wrong, you still get 100% today. How sweet is that, right? But I need you to, right, when I send them home, make sure you do them and try your best, right? You do want to do well on them if you can. So here we go. When Ryan turns 25, so I will try to always give you scenarios, and sometimes the wording is kind of tricky. So you have to try your best to navigate it. What makes sense, what doesn't make sense? What can I rule out? Okay, so at 25, decides to start a retirement and start a small investment account. Ryan plans to put in $10 a week. $10 a week. That is a regular contribution, right? At 4% interest, compounded monthly. And this is happening for 5 years. So he'll be 30 when this is done, right? Thea, did you do this, AC? No? Okay. So let's start. NI, PV, PMT. You're already done, so give me a break, okay? I'm not as fast as you think. So I start maybe I will suggest figure out if there's a PMT, if there's a payment, and there is. It's $10 a week. It's negative 10, right? You're giving it to the bank. Then I go over here, and I know that my compounding is 12 because it's monthly, 12 times a year. Payment, you go to your payment, and it's weekly. So in this case, it's 52, right? 52 times a year. How many payments a year? 52. If payment is 0, we just set PY equal to CY. It's right, like that's just what we do. Future value is what we want to find out. Present value, we don't start with anything, right? We don't have an amount to start, so it's 0. Interest is 4, and this is 5 years times 52, so this is 324. Okay, so if you have all of those and now you get your final, I'm going to actually calculate this. 5 times 52, 4, 0, negative 10, 0, 52, and 12. Alpha enter. This doesn't look right, and I see why. That's a pretty good pun. I see why. That one goes in the books. This is 12. This should be 5 times 52. So this is wrong here, right? It's looking at the wrong key. 260. So good thing, that's probably a good habit to like, let's redo it here, right? And catch it. Thank you, I heard it. So now let's try this again. Is that what we're getting? Yes? Because I didn't pull up the right key. Did I misplace it? Thought I had it here. I don't want to go through it blind because if I make a mistake, you're not going to stop me. Please stop me if I make mistakes, okay? Yes, we're good. 28, 7, 6, 64. And that is the final answer. Clearly indicate or make a statement of some sort and you're fine. So if you have this, you get the 2 marks. If you make one mistake, like one number is off, take off half. 2 mistakes, take off 1. More than 2, it's 0, right? So you don't get anything. How much interest did he earn? I like to use this one. It's from the very first to whatever n is, 260. It's 5 times PY. So you would get 260 if you go years times PY. Okay, guys? And that gives you 276.64. And of course, This would be based on what you did up here. So if you did, let's say you got 0 up here, you got nothing. You made every single one is, or most of them are wrong. I would base this answer on this. So if it jives, you do get the mark for this. Alternatively, if you want to use this other formula, it's PV. No, it's, sorry, I'm mixing them up. What is the formula again? Future value, right? Future value minus present value minus N times PMT, right? That's the other formula that I gave you. Make sure you have that on your study sheet. And that's still 276.64. Either way, you get a mark for that. Next, Ryan turns 30 at the end of the 5 years, okay? Withdraws the money from that he has accumulated. It takes that money out in A, right? If he places all the funds into a tax-free savings account at 315% compounded quarterly, how much will he have by the time he retires at 65? So let's do the time first. We're going 60 minus 30, so 35 years will go by for this particular calculation. That's first thing there. And let's figure this out. I didn't cover an example like this, but then again, I'm giving you 100% if you did it, so I think it's fair, okay? So basically, watch what's gonna happen here. I'm gonna zoom out for this. Your future value here becomes what? Your present value in this investment. So I'm basically taking it out over there and I'm investing it into a TFSA. And it's negative. Now I'm going to zoom back in.
Excuse the interruption. Leave Benang, please come to the office. Leave Benang to the office. Thank you.
Are we making any additional payments, any regular payments here? No, right? It's just sitting there. You're just putting it in, letting it sit, letting it grow. So this is 0, which means that if compounding is quarterly, then payments will also be quarterly. I want to know what my future value is. Interest rate is 3.15, and this would be 35 times whatever PY is. That's 140. Okay, so let's calculate that. 35 times 4, 315. Negative 2876.64. 0, 0 for now. 4, 4. You go to your future value, and there it is. 8,626.20. So there's a mix, right? For the first little while, we put money in, and then we change our strategy. We just let it sit and grow. So we've got both scenarios in one. Estimate the doubling time of the investment. Doubling time, what does that tell you? Like if I were to tell you doubling time, what comes to mind? The time it takes for your money to double. How could we do that using the TVM? I'll show you how to use the TVM. If you wouldn't mind copying this. I'll show you a method later how to estimate it. This would be how to find out exactly. So in this scenario, our compounding and our PY is the same. There are no payments. Our present value is negative 2876.64. Our interest rate is 315. Where is time found in? Where am I going to be able to get my time? In N, correct? N is where time is hidden. So that's the one you need to solve for. What am I going to put in for future value? What are we going to do to this number to put in here? We're interested in it doubling. 2, right? So we're going to take this, we multiply this by 2. Let me just use this on my calculator. Watch what I'm going to do on my calculator. I'm going to go to future value. I'm just going to go 2 times 2876.64. Enter. And it doubles it for you, right? 57, 53, 28. Now we're going to go all the way up to n. We're going to go alpha, enter. We're getting 88.3648, and that keeps going. How do we get our time in years? We go n divided by py. Have that on your study sheet. If you solve for n and you want the time in years, just divide n by py. So we're going to go 88.3648 something divided by 4. 88.3648 divided by 4. That's 22.09 years. It's a long time, right, to double your money? So the interest rate is the problem here. It's a very low interest rate. Once the interest rate goes higher, you'll see that that time will shrink significantly. Okay. Let me just try something here. I'm going to talk about the rule of 72 later on. You probably have never heard of it, but there's a cool trick that allows us to estimate what we just did here. It's called the rule of 72. Basically, we take 72 and we divide it by the interest rate. That's it. And if you do that, you get approximately 22 years. So it saves you a lot of time. I'll show you how to do that. I don't think I'm going to do rule of 72 here, otherwise it's going to be too much for you, right? So keep going. Geno would like to have a certain amount, 7,500 for university tuition, but he's going to work for 3 years to save up before going to university. He saves the same amount each month, okay? So what are we talking about? Regular contributions every month. That's what that is saying. That's your there's a PMT amount here at play. Interest rate, 2.5%, compounded monthly. How much will you have to save each month to reach that goal in 3 years? So here we go. PYCY. There we go. Payment is what I'm solving for, so it's not going to be 0.
Excuse the interruption. Paras Dhaliwal to the office, please. Paras Dhaliwal to the office.
That's 12. So PY is 12. CY is also 12 because it says compounded monthly, so it happens to be the same. In the future, I would like to have $7,500, right? Positive, because it's going to come to me at that point. I start with 0. There are no indications that I start with something other than 0. This is 2.5, and this would be 3 years times 12, so that's 36. So that's, in a sense, we're talking 36 months because we know that the PY is 12. So let's solve for that. 36, 2.5, 0, 0, 7,500, 12. Here we go. Go to payment. And it's $200.84. Does it make sense that it's negative? Yeah, it's leaving your account every month. It's supposed to be negative, so we're not going to worry about that. We know why that is negative, okay? That's it. You're done. 2 marks. You mark yourselves the way you think you should get out, like whatever you think you should get there. I told you how I mark this. So keep going. How much would you need to save each month if you have a retirement savings goal of $1 million and you get 6% interest compounded quarterly, given that you plan on retiring at 15 years? So this is actually important. This is a very important lesson, this one right here. I will do the TVM for both. Please give me your TVM values if you are using TVM every time, all of them, okay? Don't do shortcuts. So we're doing quarterly compounding. We're not talking, right there, it says how much you need to save each month. So our payments are going to be monthly. We want $1 million. We're figuring out the payment. We're starting with 0. The interest rate is 6. And 15 is our time for the first option. 15 times 12. That's 180. This is 6. This is 180. Alpha, enter. So you need to put away $3,447.30. Yikes. So if you're waiting, you're like, I won't save for retirement. I have too much going on right now in my life. I won't. So if you're waiting, and now you're like, shoot, I'm 50. I want to retire at 65. I only have 15 years left. You need to put in this much money every month to make that goal. Okay? Let's do another one. B. What if you start earlier? You start much earlier. Twice as long. You have twice as long to contribute. Am I missing one? No, I think I'm good. We're sticking, everything else is the same. The payment will be different. Interest rate is the same. But here we have 30 years times 12, right? So 360 payments will go by. So that means that this changes to 360. I basically just have to go to payment and look at that. Oh, 1,001.18. I want you to really think about this. You're doubling the time, right? You're starting way earlier, like 30 years left. What do you notice about the payment, like how much you have to put in? It's about a third, less than a third to reach the exact same goal. So with B, you're putting way less in, right, from your own money to achieve the same goal. That's something I want you to remember. Can I ask you to, I know this isn't asking you for it, but let's figure out how much money did we put in here from our own money and how much should we put in here from our own money. So what we call that the principal. Principal is PV plus N times PMT. Like what you put in at the very beginning and all the payments you've made. We didn't put anything in, so this is really just 180 times 3,447.30. Let's figure that out. I didn't ask you for it. This is $620,514 from your money to reach the $1 million goal. Okay? What about with option B? How many payments of 1,000 did we make? 360 times 1,001.18. $360, $424.80. What does that mean for you guys? Should you wait to save for retirement? Or should you start as soon as possible? As soon as possible, guys. Like, look, I know you're like, big deal. It's just a number, Mr. Erickson. No, look at this, look at this. If you start early, you only need to put in $360,000. The rest is all interest. The bank is doing the rest for you. You letting it sit there and it taking off. Remember the exponential growth, right? You have more time for it to like shoot up, and then you take advantage of that growth that is just kind of doing it on its own. Option A, you need to put in $620,000 of your own money to get that same goal. So option B, right, you get to save all that extra cash to do something else with it, because you don't have to put in that much to achieve your goals, okay? If you start at 20 and you go till 67, that's your retirement age. Did you know that? That's the official retirement age if you want to go Canada Pension Plan. If you want to like work till 67 till you're eligible to cash a pension that the government gives you. How many years is that from 20 to 67? 47 years. How about, because these numbers are already on our calculator, let's go to the apps. And instead of, I went 30 times 12, right? I'm going to go 47 times 12. How much do you have to put in every month? Let's see. Even less. $322 a month to get $1 million by the time you're ready to retire. And I'm telling you this, $1 million, some people might say, by the time you get to 67, it's $1 million is going to be like a loaf of bread, right? You're going to buy a loaf of bread for $1 million. I don't think so. I think it's still going to be a decent amount of cash along the way. Anyways, the power of time. The power of time. And if you have it, use it, okay? C, so let's explain C here. C, explain why the payment in B is less than half of the payment in A. I will say this. This is mainly due to the compounding compound interest. A longer time frame allows for more compounding periods. I've been talking about this since a very early stage, that the more compounding periods you have, the better. Okay? So that's basically it. That's all I'm going to say there. You have 360 compounding periods in B. You only have 180 compounding periods in A. So you don't have as many. It's almost like rolling a snowball 180 times. You're going to have a snowball, all right? But who's going to have the bigger snowball? The person that keeps rolling it, right? 360 times. It's just going to accumulate more. Yeah. Yeah. Okay, stop here.